torque experienced by a current loop in a magnetic field. So I have a rectangular loop here. This is a rectangular loop carrying a current in it. And this rectangular loop is placed in a magnetic field produced by North Pole and South Pole. So if you place North Pole and South Pole like this, the magnetic field produces from north direction to the south direction. So this is the direction of magnetic field. Now we have considered a rectangular loop. The length of this rectangular loop is L and the breadth is B. PQRS is a rectangular loop carrying a current I in it. Now here I will divide this entire rectangular loop into 4 parts. So here it is PQ and RS. These are the lengths. One part I will consider. There are 2 parts, this one only. And here QS and PS you are observing in a diagram. These two are again the 2 more parts of the rectangular loop. So PQRS are parallel to each other and these two are perpendicular to these QS and PS. That's what you observing in a diagram. Now when a current is passing through PQ, what happens? When a current is passing through PQ, it experiences a force. The force experienced by PQ is given by force F is equal to I B L sine theta. This is the formula, we already studied it. So F is the force experienced by a conductor carrying a current I in a magnetic field B having a length L, where theta is the angle between the magnetic field and the length. Now what is the angle between this length and magnetic field? You see the magnetic field is like this from north to south, but the length is considered to be perpendicular to the magnetic field, right? So this is the magnetic field and this is the length. So both are perpendicular to each other, therefore theta is equal to 90 degree. Therefore the force experienced by a conductor PQ is equal to IBL. But what is the direction of this force? For that you need to apply the Fleming's left hand rule. From Fleming's left hand rule, the central finger points in the direction of current. So the central finger is pointing in the direction of current, and the magnetic field direction is represented by the forefinger. So the forefinger represents the direction of magnetic field. So direction of magnetic field is represented by the forefinger, and where the thumb points, if you stretch mutually perpendicular to each other, all the first 3 fingers, so the central finger represents the direction of current and the magnetic field is represented by the forefinger and the thumb points inward. You can do yourself. So you are going to get the thumb points inward. So the force on PQ is inward. So it starts moving inside the plane of the paper where I am writing it. So inward, I wrote it into mark. Now, what about one more conductor? This is RS. So now we found it for this force is for PQ, right? Then what about force on RS? Therefore, the force on RS is given by same formula IBL sin theta. I is the same current which is passing through the conductor RS, and L is the length of the conductor RS, B is the magnetic field in which that conductor is there RS, and theta is again 90 degree because magnetic field and length is perpendicular to each other. Therefore, the force on RS is equal to IBL. But what is the direction of this force? The direction of force on RS is, it is upward. Again, you can apply the Fleming's left hand rule. The central finger should point inward, points in the direction of current, and the magnetic field will be from north to south. Then where the thumb points upward. So dot. So these two forces, force on PQ and force on RS, are equal but in opposite direction. You see, both are equal, IBL and IBL, but they are in opposite direction. So force on PQ is inward, force on RS is upward. So it is like this. The force on PQ, which is inward, and on RS, which is upward. So two forces acting equal but in opposite direction. As a result, this conductor start rotates. So it experiences a torque, and that torque is given by, what is the formula of torque? The torque formula is equal to torque, tau is equal to force into perpendicular distance between the force, or arm we will call. So force, any one of the force you can consider, magnitude of force, which is IBL, both are equal. Arm, what is arm here? The distance between these two forces. So the force acting on this conductor is inward, and the force acting on this conductor RS is upward, right? So as a result, it starts rotates, and this length, the distance between two forces, is B, right? So B it is. So that's what I'm going to consider it now, B. So I will write it I, B, and L into B. What is L into B here? Length into breadth. Length into breadth is equal to area. So I will write these two together as area. Now, what about these two together is called? I will rearrange it IAB. What is I into A? I into A is called as magnetic moment, and B, we are going to write it. So the maximum torque experienced by a rectangular loop, torque, which is equal to M into B. Or in any other position, if the conductor rectangular loop is in any other angle, then we can write the torque tau is equal to MB sine theta. It is other than 90 degree. If the conductor is made some other angle than 90 degree, then MB sine theta we can write it. Or we can write in vector form, torque tau is equal to M cross B. So we already know, we studied in the first year, MB sine theta or AB sine theta is equal to A cross B. So that's what we applied it here, and this is the final result of the torque. The torque experienced by a rectangular loop in a uniform magnetic field. Okay, now, so the force experienced by the conductor PQ and RS constitutes a torque. Maximum torque these two conductors will experience. But what about QS and PS? Here, sorry, it is QR and PS. QR, this is QR and PS. So QR and PS, these are the two conductors here. Actually, these QR and PS are parallel to the magnetic field applied. Right? Magnetic field is in this direction, and this PS and QR also in the same direction. You can see. So this is the direction of magnetic field, and PS as well as QR in the same direction as that of magnetic field. So what is the angle between them? So angle between them is equal to 0. Therefore, what should be the force experienced? Force experienced by these two conductors. So force experienced by these two conductors is given by VL sine theta. But what is theta here? Theta is equal to 0. Therefore, force experienced by those two conductors is also 0. That is why we have not taken into account only QR and only PQ and RS are taken into account. They will constitute a torque.